All right, let's get right into it. We're going to talk about a mistake that's super common for developers, but also absolutely catastrophic. I'm talking about accidentally committing your secrets to a public repo. And believe me, this isn't some textbook theory. This is the kind of thing that can drain your bank account in like a few hours. The good news? It's 100% avoidable. So picture this, right? It's Friday. It's 5 p.m. You've been grinding all week on a brand new feature. Everything's finally working. The tests are all green. You've got that amazing feeling. You're ready to ship it. You're literally just one Git push away from freedom in the weekend. But what if that single, innocent-looking commit ends up being the most expensive one of your life? Yeah, this is the story of the $72,000 commit. And this is the scary part, because it looks so normal, you know? On the left, you've got your standard config file, port number, database connection string. Oh, and look at that, right there, just sitting out in the open, your AWS keys, your Stripe key. And on the right, the command you run a dozen times a day without even thinking: git add, git commit, git push. And just like that, boom, the keys to your entire digital kingdom are now public. And you want to know how fast the disaster unfolds? It's insane. At 5:01 p.m., you hit enter on that git push. By 5:03 p.m., that's just 2 minutes later, automated bots that do nothing but scan GitHub 24/7 have already found your keys. And before you've even closed your laptop, those bots are firing up hundreds of massive servers on your AWS account to mine crypto. By the time you wake up and grab coffee Saturday morning, it's already too late. The damage is done. And the fallout? It's just staggering. You're looking at an overnight AWS bill for 72 grand, plus another $15,000 in fake charges hitting your Stripe account. Your cloud provider has suspended you and your CEO is on the phone, and it's not a happy call. All of that from one simple git push. And look, don't think this is just some horror story we made up. This happens to the big guys too. Uber, back in 2016, AWS keys leaked on GitHub. The result, a breach of 57 million user records and a settlement that cost them $148 million. Toyota, Tesla, they've all had this happen publicly. So yeah, this is a very, very real threat. Okay, so how could this whole nightmare have been avoided? Well, the first line of defense is actually incredibly simple. It's called environment variables. So how do these work? It's pretty straightforward. Instead of hard-coding a secret right in your config file, you just reference it. You use something like process.env to say, hey, go grab this value from the machine you're running on. And where do you store those secrets locally? In a file called .env. Now, and this is the most important part, so listen up. You add that .env file to your .gitignore. That's it. That one line tells Git, hey, never ever track this file. Your code stays clean, and your secrets never even get close to your repository. Okay, so we keep saying the word secrets, but what are we really talking about here? Let's be clear. These are, quite literally, the keys to your entire digital kingdom. Basically, a secret is any piece of data that can let someone in or prove who they are. We're talking API keys, database passwords, those TLS certificates, auth tokens, the whole shebang. If an attacker gets their hands on these, they don't need to find a fancy bug in your code. They can just unlock the front door and walk right in. You can kind of think of them in 4 main buckets. First, you've got credentials, like your database password. That's your door key. Then there are certificates. Think of those as your official ID, like a driver's license, proving you're legit. Third, encryption keys. That's the combination to the safe where you keep your most valuable stuff. And finally, third-party tokens, like that Stripe key. That's literally your company credit card. And you wouldn't just leave any of that stuff lying on a park bench, would you? Now, environment variables are awesome for when you're working on your own machine. But when you're talking about your live production systems, you need something way more secure. I like to call this the safe deposit box rule. Think about it like this. Hard-coding secrets in your code, that's like walking around a crowded city with all your cash, your passport, and your house keys just hanging out of your back pocket. It's just asking for trouble. A secrets manager, something like AWS Secrets Manager or HashiCorp Vault, is the exact opposite. It's like putting all those valuables in a super secure bank vault. And the whole process works just like a trip to the bank. First, your app has to walk up to the teller and show some ID to prove it has an account there. That's usually handled by something called an IAM role. The secrets manager checks the ID, makes sure everything's legit. Then your app says, okay, I need the key from safe deposit box 123. And the manager goes and gets only that one specific key. And the best part? Every single one of these transactions is logged. You have a full audit trail of who accessed what and when. All right, so now that we know what we should be doing, let's talk about what not to do. Let's cover the 3 most common mistakes. I call them the 3 deadly sins of secrets management. Sin number 1, and this is probably the most common one, is committing your .env file. And here's the thing you have to burn into your brain. Once something is in your Git history, it's there forever. Seriously, even if you delete it in the very next commit, the original commit with that secret is still there, just buried in the history like a digital landmine waiting to go off. So the rule is simple, and you have to make it a habit. Always, and I mean always, create your .gitignore file and add .env to it first. Do that before you even create your .env file. It's a tiny habit that completely eliminates the chance of an accidental commit. Deadly sin number 2, logging your secrets. I get it. We all love to log stuff for debugging. But if you print an API key or password to your logs, you haven't solved the problem. You've just moved it. Now that secret isn't just in your code, it's in your logging system, which probably stores data for months, even years, and is often accessible to way more people than just your dev team. And the fix here is so easy. Instead of logging, connecting with API key, scale, live, blah, 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 just log something like successfully connected to Stripe API. That's it. Or log some other non-sensitive info, like a transaction ID. You still get the confirmation you need for debugging, but you don't expose the key. And finally, sin number 3, using the same key everywhere, for your dev, staging, and production environments. Look, your developer laptop is just not as locked down as your production servers. It can't be. So if an attacker gets a key from a dev machine, that one key should absolutely not be able to unlock the front door to your production database. The whole idea here is about containing the damage, limiting the blast radius. When you use unique keys for each environment, a breach in dev, well, it stays in dev. It's an annoyance, for sure, but it's not a company-ending catastrophe. Whew! Okay, that was a lot. So, let's boil all of this down into a simple, easy-to-remember security playbook that you can start using, right now. Here are the 4 big rules. Number 1, never, ever, under any circumstances, commit secrets to Git. Just don't. Number 2, for your local dev work, use environment variables and get that .gitignore file set up first. 3, for staging and production, step it up and use a real secrets manager. And 4, rotate your keys on a regular basis, especially if someone who had access leaves the team. And that leaves us with one last question, a little bit of homework for you. After watching this, you kind of have to go look, don't you? So what secrets are hiding in your Git history?